Like any star, it will run out of fuel in its center and begin transforming. It will start bulging and will engulf Mercury and Venus, coming extremely close to Earth. Lethal juice is passing on this news, and it has been a hard pill for scientists to swallow, but there is nothing they can do about it. The massive star is going to go supernova anytime soon. Astronomers say it could be tomorrow, next month, or a few months from now. They don't know the exact date. However, one thing is sure, the famous Betelgeuse has reached its end, and its death is going to change our experiences. What's so special about the Betelgeuse supernova that has everyone scared? What might happen if this star exploded today, as scientists have predicted? Join us on this fascinating venture as we explore the answers to these questions. In today's video, NASA's chief announces that Betelgeuse's supernova is expected to explode in 2024, and there's nothing that can be done to stop the impending destruction. NASA's boss issues a warning about the coming Betelgeuse supernova that could disrupt life as we know it. Betelgeuse's end is imminent, and like a terminal patient, the star is moving closer to its grave. It's only a matter of time before the famous star explodes and ceases to exist. For a long time, astronomers have been fascinated by Betelgeuse, spending years studying the star's features and its impending explosion. What astronomers have long feared is about to happen. There is no stopping the inevitable. Betelgeuse is headed for extinction, and its end is coming sooner than we expected. BJW is one of the most extraordinary stars in the Milky Way, captivating astronomers for centuries. For ages, astrophysicists have been mesmerized by this red semi-variable star, whose apparent magnitude fluctuates between 0.5 and 1.6. Compared to other stars, Betelgeuse stands out as a first-magnitude star with the largest range. The classical astronomer T described Betelgeuse as more or less orange. Ptolemy, an Alexandrian mathematician, astrologer, astronomer, and geographer, spent years studying Betelgeuse. His research and observations provided one of the earliest depictions of the red giant star. Interestingly, even indigenous groups in South Australia have shared oral stories about Betelgeuse's variable brightness for at least 1,000 years. Advancements in astronomy have given scientists a more accurate picture of Betelgeuse and its characteristics. This red supergiant star is located in the constellation Orion and is one of the largest stars out there. Red supergiants are some of the biggest and most massive stars in the universe. Their width, which spans from 100 million to 1 billion kilometers, makes them one of the wonders of the Milky Way. If we were to place BJW next to the Sun, the star is 100 to 1,000 times wider than our Sun. According to research, scientists tell us that a red giant star is a dying star in its final stages of evolution. Despite the common features between a red supergiant and a red giant star, there is a major difference. Unlike a red giant, which forms when a star with the mass of our Sun runs out of fuel, a red supergiant forms when a star with more than 10 solar masses enters this phase. A red supergiant occurs when it can no longer generate the heat and pressure needed to sustain its weight, causing it to collapse. Betelgeuse's amazing features extend to its brightness, being the 10th brightest star in the night sky and the second brightest in its constellation, just behind Rigel. However, if we were to observe it at near-infrared wavelengths, no other star would take Betelgeuse's crown as the brightest star in the night sky. The Sun's brightness would fade greatly when placed next to Betelgeuse's enormous frame. If Betelgeuse were at the center of our solar system, its surface would extend beyond the asteroid belt, engulfing the orbits of Mercury, Venus, Earth, and Mars. From years of research, scientists estimate Betelgeuse's mass to range between 10 and 20 times that of the Sun. The most surprising discovery is that this star is around 600 light-years away from the Sun, which means it's in our cosmic neighborhood. However, astronomers were startled to learn that Betelgeuse is less than 10 million years old. By cosmic standards, it is a young star, a mere infant compared to our ancient Sun, which is around 5 billion years old. However, what Betelgeuse lacks in age, it makes up for in size. Its size dwarfs most stars in the universe. Although scientists have tried their best to measure Betelgeuse's exact diameter, it has been a monumental task because it is a pulsating star. This means its diameter changes over time. Another reason this crucial information has eluded scientists is that Betelgeuse has no clear edge. Limb darkening causes the optical emissions to change in color and diminish as one moves farther from the center. Additionally, BJ is surrounded by a circumstellar envelope made up of matter ejected from the star, making it difficult to define the photosphere. Betelgeuse's apparent size also depends on the wavelength used. As if that wasn't enough, atmospheric shimmering also plays a role in limiting the resolution of images from ground-based telescopes since turbulence degrades angular resolution. As you can see, many forces make it difficult to determine Betelgeuse's exact diameter. However, this hasn't stopped scientists from coming up with estimates of what they believe this massive star's diameter would be like. Aside from its diameter, another puzzle Betelgeuse has presented to scientists is the complex dynamics of its extended atmosphere. Scientists are well aware that the mass that makes up galaxies is recycled as stars are formed and destroyed. However, they have yet to answer the question of how mass is lost. As intriguing as this mystery might sound, it is nothing compared to the latest discoveries scientists have made from studying BJW. It's no secret that Betelgeuse has an enormous mass, but what many don't know is that this is why it has evolved so quickly over the years. In numerical terms, we can draw a straight line from Betelgeuse's increasing mass to its growth over a long period of time. On this note, you won't be shocked by the bombshell we are about to drop next: Betelgeuse is dying soon. The red giant star is expected to end its life in a supernova explosion anytime now. When astronomers discovered that Betelgeuse was destined to go supernova, the scientific community was on high alert. A supernova is a powerful and luminous explosion of a star. Scientists explain that a supernova occurs during the final evolutionary stages of a massive star or when a white dwarf is triggered into runaway nuclear fusion. What happens next is that the progenitor either collapses into a neutron star or black hole or is completely obliterated to form a diffuse cloud. If Betelgeuse exploded today, the optical radiance of the cosmic explosion can be contrasted with that of a whole world. Prior to blurring, following a little while or months, the sheer sight of this occasion would either unnerve or energize its watchers. One more charming reality about this red giant star is that it is apparent to the unaided eye around evening time. However, scientists still can't understand the truth that the red giant is nearly inconspicuous starting from the earliest stage in May and August, since it is near the Sun. This is one of the secrets encompassing Betelgeuse. Another invigorating fact to remember is that Betelgeuse is one of the 3 stars that make up the winter triangle asterism, and it denotes the center of the winter hexagon. From the beginning of January each year, the star should be visible rising in the east soon after nightfall. By mid-March, it is apparent to practically every occupied area on the planet, except Antarctica, at a latitude south of 8 degrees. On a typical day, once sunshine bids farewell to the Earth and the night's darkness sets in, it is possible to detect Betelgeuse among the variety of stars that decorate the sky. So, if Betelgeuse were to detonate today, everybody would see its outcome. It would be as noticeable as if we were watching a 3D live-action film. Everybody would know that something has gone off in the smooth manner. The cosmic explosion would appear here as a very brilliant mark of light overhead, possibly creating shadows around nighttime. A Betelgeuse supernova would shine as brightly as the half-moon for over 90 days, changing the substance of what occurs on Earth. Assuming you question this, remember that Betelgeuse is only 642 light-years away from Earth. Allegorically speaking, the stars are a secondary neighbor. There is no escaping the inevitable. We would undoubtedly feel the effect of this strong blast. Before we dive further into the effect of Betelgeuse's blast, it's essential to mention that the star's brilliance isn't consistent. This may come as a shock to many individuals, but it shouldn't be if we recall that Betelgeuse is a pulsating semi-regular variable star. This information helps us understand why Betelgeuse is subject to different patterns of increasing and decreasing brightness due to changes in its temperature and size. The first time astronomers uncovered this quirk about Betelgeuse was in 2019. The credit goes to Villanova University astronomers Richard Wannick and Edward Jinan, and amateur stargazer Thomas Calderwood. they were the first to observe that Betelgeuse's brightness was diminishing. It seemed like they were in a dream then, since nothing like this had been seen before. However, after conducting various tests, the researchers concluded that it was indeed a reality. They further determined that an occurrence of a typical 5.9-year light cycle, at least and deeper than normal, was responsible for the unusual event. By late 2019, speculation of other potential causes arose, suggesting that the event might have been caused by an ejection of gas or dust or fluctuations in the star's surface brightness. The succeeding months saw astronomers spend time investigating this unexpected event. Thanks to bright observations made by the Hubble Space Telescope, HST, a new theory was proposed by August 2020. Researchers believed that the dimming could have been due to a huge amount of super-hot material ejected into space. This material ended up cooling and forming a dust cloud that blocked the starlight coming from about a quarter of the star's surface. The captivating ticket here is that Hubble had captured indications of thick, heated material traveling through the star's atmosphere in September, October, and November before several telescopes noticed the more pronounced darkening in December. In the early months of 2020, astronomers found that Betelgeuse had dimmed by a factor of around 2.5, from magnitude 0.5 to 1.5. The situation worsened in February as researchers reported that the star was currently the least luminous and coolest in the 25 years of studying it. As soon as news of this event reached the public, speculation spread that Betelgeuse could explode as a supernova. This narrative also gained traction when NASA's nonverbal communication shifted in the same direction. However, normalcy began to return when, by February 17, 2020, Betelgeuse's brightness had remained steady for around 10 days. Additionally, researchers were pleased to observe that the star had started showing signs of re-brightening by February 22, 2020. Betelgeuse was believed to have stopped dimming altogether, putting a curtain over the darkening episode. Further investigations conducted on February 24, 2020, brought a new perspective to our understanding of the possible cause of this event. Researchers announced that including large grains of circumstellar dust might have caused the dimming of Betelgeuse. We thought this dimming episode was a relic of the past until news came bearing the unfortunate update that Betelgeuse was dimming again, a discovery verified by the American Association of Variable Star Observers and NASA. Juice has darkened by around 0.5 greatness since late January. This revelation made it to the news on spring 14, 2024, and has placed everybody on their toes as we guess what occurs next. On the off chance that we stop examining the change of Ball's splendor briefly, we can't help but spot the genuine glaring issue at hand, Betelgeuse's approaching blast. The prospect of what the scarab juice blast could do to our planet has sent many into a condition of panic as minds have roamed free on the vast possibilities that could emerge from this occasion. Anyway, cosmologists rush to ease everybody's fears and have spent time assuring us that life on Earth will be safe. They have even gone further to declassify records that show that creepy-crawly Juice's blast will occur within 100,000 years, so it very well may be centuries from now before it happens. As consoling as these statements may sound to the ear, a few stargazers keep painting to us the shocking picture of what a supernova can do to our planet. For those who will be alive when Ball Juice detonates, they would see that the star shines far more brightly than any other star or planet. The energy released during Ball Juice's blast can have a serious effect on the surrounding space. What's alarming is that we are yet to find out the extent of its influence on our planet. Assuming we are being genuine with ourselves, there is a need to be frightened of a blast that would release a massive amount of energy, estimated to be as much as the energy released by the sun in its entire lifetime. That's a lot of radiation coming from just one event. All that radiation, including gamma rays, X-rays, and cosmic rays, would no doubt have a significant effect on Earth's environment. As some scientists fear, it could be harmful to life on Earth. Researchers have admitted that this radiation can damage DNA and other cell structures and possibly cause cell death, mutations, and cancer. So, it's in our best interest that this radiation never reaches our planet, as the mere thought of the potential health issues that might arise is quite frightening. All things considered, investigations have shown that it isn't all doom as some projections would have us believe. Astronomers have assured us that the Earth's atmosphere is capable of shielding us from the majority of the harmful radiation that might be generated when Betelgeuse goes supernova. Hence, despite our fears, it would only have a minor effect on life. We see evidence of this possibility when we consider the fact that the brightness of Betelgeuse's supernova would create shadows at night. This event isn't good news for nocturnal creatures that rely on darkness to hunt, navigate, and communicate. Owls present us with a nearly perfect example of this possibility. These nocturnal creatures depend on intense night vision to hunt and navigate in the dark. However, Betelgeuse's blast is going to change the cards on these innocent creatures. The increased brightness generated by the supernova could hinder their ability to see in the dark. This is a serious issue since it could become harder for the owls to hunt and avoid predators. Besides, some insects, like fireflies, which use bioluminescence to communicate with each other, may have their activities disrupted. This is because the increased brightness from the supernova could interfere with their ability to communicate with their companions in the firefly world. Furthermore, this could alter their behavior and mating patterns. Creatures are not the only ones at risk of being affected by the supernova. The increased brilliance could also impact the ecology of the area. For example, the increased light pollution could disrupt the migration patterns of birds and could impact the behavior of insects. When this happens, it is only a matter of time before the balance of the ecosystem is disturbed. A look at some of the models used to assess the extent of the supernova's impact shows that it could cause changes in the ozone layer and alter the climate for a period. If we take our eyes off the environment for a moment, we will realize that Betelgeuse also affects astronomy. The event will undoubtedly provide astronomers with the unique opportunity to further explore the properties of a supernova. Moreover, scientists would get to learn more about the life cycle of massive stars and uncover facts about this area that we never knew existed. Hopefully, this new star can live up to its greatness. For now, we should keep our fingers crossed for whatever wonderful story the universe intends to write with Betelgeuse's supernova.